So I'm going to start this video with number 9/10 on the sheet that starts with in-class practice, putting it all together, because this is one way that they could possibly give you the information. So here we see that this is one way they could give us the information. In class, we went in the reverse direction from the graph to these signs. Now we're going to be given these signs, go to the graph. So what we're going to do first is use this chart to write our intervals, increasing, decreasing, that sort of thing. So it's increasing wherever the derivative is positive. So in this case, it is increasing from negative infinity to infinity. And it is decreasing nowhere, so we don't have to have that. And it is concave up wherever the second derivative is positive. So it's concave up from negative infinity to 1 and 3 to infinity, which means it's concave down from 1 to 3. And then I think it helps sometimes to just draw the first derivative interval testing thing. You don't actually have to interval test, but we know it would look like this. 1 and 3 would be here, and we know that it would be increasing the whole way. So we have a chance of inflection points. We have no relative maxes or mins, maxes or mins. And so when we do the second derivative test, we see that we have these same numbers here, and we see that it was positive, negative, positive, which means negative, positive, we have 2 inflection points. So if you look here, there's an inflection point here and an inflection point here because the concavity changes. We don't know what f of 1 would be or f of 3 would be because we don't have an original equation to plug it into. But we're just going to go with what we have to draw the basics of what we know. So what the heck am I talking about? By the way, I answered number 9 right here. I did forget the one part about inflection points. So inflection points at x equals 3 and x equals 1. And we're going to use all this information to draw a graph. And keep in mind that everyone's graph could look different because we don't have any exact numbers to go by. So we're just going to look at it the way I do it and know that you draw it slightly different from me. But some major things that have to stay the same is that you have to have an inflection point at 1 and an inflection point at 3. Now, we don't know if this point is here or if this one's up here. So this is where they can be different. The graphs can be different, like the ones you draw and the ones I draw can be slightly different based on how you do it. The key things we're looking for is that it is increasing over the whole thing. So basically, I have to make sure I keep going up. And it is concave up from negative infinity to 1. So we've got to be increasing and concave up here. I'm just going to go ahead and put the inflection point right on the axis. Why not? Makes life easy. So increasing and concave up, and then the concavity changes between here and here. And I'm just going to put this point up here. It doesn't matter where I put it, but I'm going to go concave down, and then it's an inflection point. So from here, it goes concave up. So when I look at this, I'm just going to go, okay, did they do it increasing the whole time? Yes. Is it concave up from negative infinity to 1, 3 to infinity? Is it concave down in here? Do I have relative maxes and mins? No. Do I have inflection points? Yes. So that's the gist of what's going on. And now let's go to that other worksheet that has a couple of practice problems on it. It just says graphing practice at the top.